One search is not enough for hard RAG questions. This is the pattern you'll be able to implement by the end, which decomposes a hard question into steps and synthesizes an answer from per-step evidence. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Multi-hop retrieval augmented generation with query decomposition solves a common pain point. You ask a question that needs 2 or more linked facts. A single retrieval call pulls noisy or partial evidence. Success means breaking the question into manageable hops, retrieving focused facts for each hop, and composing a confident final answer. Teams use this when single-shot answers hallucinate or miss supporting facts. It can change accuracy on fact chains from shaky to reliable for small to medium corpora where careful evidence chaining matters. Intuitively, query decomposition turns one hard question into a short chain of focused questions. Imagine asking who won a sports title, then where that winner is based. Instead of searching for both facts at once, you ask the first thing, extract the entity, then ask the second thing using that entity. The strength is clarity. Each hop is easier to match to a document. The weakness is dependency. If hop 1 fails, the whole chain weakens. That trade-off is manageable with simple scoring. We will build a tiny demo that shows the whole loop. First, we create a small in-memory corpus and a basic keyword retriever. Then we decompose a complex question into 2 hops. We run hop 1 to find the entity, run hop 2 conditioned on that entity, compute a compact chain score, and wrap the chain into a function that returns the final answer. This keeps the code readable and shows the core ideas without heavy libraries. Now we set up the corpus and a primitive retriever, so our later hops have something to query. This snippet builds a small in-memory corpus and a basic keyword overlap retriever to ground later multi-hop logic. The variable docs stores short facts we will retrieve from. The function toke lowercases text, strips punctuation into spaces, and splits into tokens for simple matching. The function retr computes a score per document as the fraction of unique query tokens found in each document's tokens, then returns the top results sorted by score. Finally, a direct question about the 2019 title is issued, and the highest scoring document index and score are captured. The printed score confirms we can rank documents and identify a likely single hop answer. Next, we split the complex prompt into 2 targeted sub-questions, so each is easier to answer. This example shows a simple query decomposition that splits a complex question into 2 sub-questions. The function decompose returns a first hop to find who won the 2019 title, and a second hop template that asks for the home city given the team. The variable hops holds these 2 sub-questions for the original complex prompt. Using the retriever ret, the first hop is answered by selecting the highest scoring document index. The variable team extracts the leading token from that document as the entity name we will carry forward. The printed team shows the entity found by hop 1, which we will feed into the next hop. Now, we condition the second search on the entity we found, so retrieval narrows to the right fact. This code performs the second hop by inserting the team from hop 1 into the city-focused question template. The variable QCity becomes a targeted query that explicitly mentions the entity, which tightens the match space. The retriever ret ranks all documents for this refined query, and city index selects the highest scoring candidate. The variable city pulls the leading token from the chosen document as the answer to this hop. The printed city shows how entity-conditioned retrieval surfaces the correct supporting fact needed to complete the chain. Next, we compute a compact score that tells us how confident to be in this 2-hop chain. This snippet computes a simple chain score by multiplying per-hop retrieval scores and adding an entity presence boost. The variable h1 stores the first hop score, while h2 is the second hop score from the city query. The variable boost applies gamma when the selected city document actually contains the team token, rewarding consistent evidence. The final chain score multiplies the hops and the boost, yielding a compact confidence estimate for the multi-hop reasoning path. Increasing gamma emphasizes consistency and can raise the chain score. Decreasing it reduces the effect and makes the score closer to the raw product. The printed chain score reflects boosted confidence for coherent evidence. Now we wrap the process into a single function that runs the end-to-end chain and returns the answer. This example wraps the multi-hop flow into a compact function that produces a final answer. The function runChain first calls decompose to get the 2 sub-questions. It retrieves the top document for the first hop and extracts the team token T. It then formats the second hop template with that team, retrieves the best city document, and extracts the city token C. The function returns the city as the synthesized answer to the original question. The printed answer confirms that the end-to-end chain returns the expected city using decomposed retrieval rather than a brittle single shot. Mapping this toy to a real project is straightforward. Replace the simple retriever with TF-IDF or FAISS for larger corpora. Keep the same decompose, extract, and condition pattern. Use the chain score to decide when to ask a model for a final natural language synthesis or when to surface raw evidence. Recap. Multi-hop RAG with query decomposition turns one hard question into a chain of focused retrievals conditional on intermediate answers. Use it when answers require linked facts and single-shot retrieval fails. One caveat is error propagation. An early wrong hop can mislead later hops unless you detect low chain confidence. Next step, tune the consistency boost gamma and measure how it changes accuracy on held-out chains. Or swap the retriever for an ANN index like FAISS and tune nprobe for speed versus recall. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.